building optimized Java microservices with Micronaut 3 and GraalVM. Please welcome Graeme Rocher.
Thank you very much. Thank you. It's a super pleasure to be here. Actually, my first time at Jfokus, first time in Stockholm, so it's an amazing experience to be here with you all, and especially after the last 2 years, I can imagine all of you feel the same. And thanks for coming to this talk on Micronaut and GraalVM and building optimized microservices. My name is Graeme Rocher, as I mentioned. I am an architect at Oracle Labs. I'm also the creator of several relatively well-known open source frameworks in the Java world. How many of you have heard of Grails? Quite a few hands, right? So there's that one. And then more recently, Micronaut. How many of you have heard of Micronaut? OK, a few hands. That's a good sign. So if you haven't heard of Micronaut, as an introduction to the technology, Micronaut is a relatively new framework focused on modern architectures, so serverless, microservice, and so forth. And it works by essentially plugging into the Jdbc compiler through the use of annotation processing, and with the purpose and the goal of increasing developer productivity by essentially adding compile time checking that a lot of frameworks today are missing. So a lot of frameworks in the Java space, you may be familiar with things like Spring and so forth, make extensive use of annotations. And Micronaut is the same. It has an annotation-based programming model, much like Spring. But the difference is Micronaut's is type-checked at compilation time by integration directly into Jdbc. And also, all of the way the framework works is computed during the compilation phase. So all the analysis of what classes are annotated with what annotation, all the endpoints in your REST application. So when you have at get, at post, at etc. We work all that at build time, eliminating the need for using any kind of Java reflection, any kind of dynamic class loading. So I spent quite a bit of my time in Grails land and in Spring land debugging, for example, class loading issues. And none of those exist in Micronaut because there's just a system class loader. There's no special class loader hierarchies. There's no dynamic class loading. It's all the system class loader. It's all reflection free. So stack traces are smaller, easier to debug. And in general, Micronaut is a general purpose programming model. So it has at its base, much like Spring, a dependency injection model. And then it has different runtime environments that build on top of that. So the most common one is the HTTP server that's based on the Netty IO toolkit. But you have people using Micronaut without Netty. You have people using Micronaut to build command line applications, to build message-driven microservices that are completely headless and just listen to Kafka queues. You have, even people using Micronaut in desktop scenarios, combining it with JavaFX. So there's really a lot of different use cases for Micronaut. But you can find out more at micronaut.io. And you can check out the source code. Do star us on GitHub. It's a great way to support your open source projects that you're interested in. Just head over to GitHub and star the repository. And do follow all the work that happens there. In addition to that, Micronaut has a great relationship with GraalVM. So GraalVM, if you had just been in a Linux talk, you may have already be up to speed with what GraalVM is. But essentially, if you haven't, it's a new, relatively new virtual machine out of Oracle Labs that is able to plug into the regular JDK's JIT. And in JIT mode, it's able to, depending on the workload, reduce latency and increase throughput. Probably more well-known is the fact that it can compute Java applications into self-contained native binaries by using the native image tool chain. And this is great for cloud deployments. It's great for serverless. It's great for command line applications, lots of different use cases. And it also has other aspects to it. It's really a broad set of technologies. There's things like the Truffle language framework with different implementations that build on it, and including implementations for things like JavaScript and Python and Ruby. and really a whole suite of technologies, and but where there's kind of a lot of crossovers between Micronaut and Native Image. So you can find out more about GraalVM at graalvm.org. And again, there's a whole bunch of demos that you can try out GraalVM on GitHub. So like I said, Micronaut and GraalVM have a very close relationship in that they essentially work great together. And the reason for that is Native Image has really great support for Java reflection, but you have to kind of tell it about it ahead of time. So it has great support for dynamic class loading, reflection, all these kinds of things. But you have to provide configuration to the Native Image tool to say, I'm using reflection over here. These classes need to be dynamically loaded. These classes need to be dynamically proxied. And all that configuration has to be provided to the tool before you can build a native image. And with Micronaut, you don't have to provide any of that, because Micronaut doesn't do reflection, doesn't do runtime proxy generation, doesn't do runtime bytecode generation, doesn't do any dynamic class loading. So it's like Micronaut is just ready to be converted into a native executable, right? And once you do, you have drastic improvements to startup time. So startup time can drop to the low millisecond range. Memory consumption drops a lot. And this makes it possible to take Micronaut applications where they couldn't go before. So what does that mean? Like before, before GraalVM Native Image, it was challenging. It was possible, but it was challenging to run Micronaut applications on IoT devices, on a Raspberry Pi, for example. But you can, because of the low resource requirements of a native executable, you can get your Micronaut apps running in all these contexts in IoT and serverless, in low memory footprint microservices, which is the topic of this conversation. So if any of you have been to one of my presentations before, it's kind of low on slides and high on demo. Hopefully I still have time to do a bunch of demos for you, and we'll hopefully have a good time, and hopefully things don't go horribly wrong. But if they do, we'll still have a good time, right, figuring them out. So what I'm going to be demonstrating today is building a simple Micronaut application and converting it into a native image and some of the features of the Micronaut framework. So to do that, I'm using the Visual Studio Code tooling that we also build at Oracle Labs. So a reminder, I work at Oracle Labs. We have a team building Visual Studio Code tooling at Oracle Labs. And it's fantastic that I get to present in front of you all the tooling that we're building at Oracle Labs. It's kind of our way of dogfooding. So I have installed here the GraalVM extension pack for Java. So this is all you need. The clean VS Code installation, just install the GraalVM extension pack for Java. And it lets you configure one or many GraalVM SDKs. I've got the one for Java 17 set up. I love Java 17 records. I love sealed interface. I love sealed types, all the great new features of Java 17. So I have that as my default go-to JDK, and you should too. So I have it set up already. And in addition to that, when you install the tools, you get the Micronaut tools installed by default. So I can immediately start building an application, and I can bootstrap an application right from my IDE. Now, there's great IDE support in other IDEs as well. The JetBrains folks with IntelliJ have built phenomenal support for Micronaut in IntelliJ as well. So, I think the diversity of tooling options available for Micronaut is a great sign that the technology is being adopted by tool vendors. And really great tooling being provided for it. So what I'm going to do is I'm going to create a Micronaut application. And when you create a Micronaut application through this tooling window, it actually communicates to start.micronaut.io. So start.micronaut.io is our project generator. If I'm not using Visual Studio Code, I can head over there and through the browser do all of the same things I'm going to do in the IDE. So I can create my Micronaut application, choose my version, my language preference that I want to build, whether I'm building using Gradle, whether I'm using Maven, my favorite testing framework. I'm a big Spock fan, but Junit 5 is awesome too. And once you're done choosing the features, For example, I can click here and I can choose, I don't know, data. And I get all these options for things like integration with Oracle Coherence or Jdbc or JPA or whatever. There's a whole bunch of features that you can choose. And then once you do, you can click Generate Project. And when you generate a project, you can download it as a zip file, or you can push the code to GitHub directly. And I can do all that through the IDE as well, which is what I'm going to do over here. So I'm going to create a Micronaut application. I'm going to use GraalVM, the Java 17, call it demo. I'm going to give it a package. I'm going to use Java. And I'm going to choose some features that I want to include in my application. Now, there's a lot of features that Micronaut supports, a lot of different ways to use Micronaut. Like I said, you can use gRPC. You can build GraphQL applications. You can build REST applications. You can build message-driven microservices. But in this case, I'm going to build a simple microservice that's going to use Micronaut Data Jdbc. So I'm going to choose that feature, click OK. I'm a Gradle fan, that is true, but Maven is an equally relevant option here. I'm going to use JUnit, and I'm going to create my application here. And it will immediately import into my IDE. So here I have my Micronaut application. It's just like any Java application in that it is essentially you have an application main class, and you have a test directory with the source test in your source test example directory, and you have a build.gradle already set up. So what I'm going to do quickly, because I'm noticing that for whatever reason the IDE tooling is not, probably because I rebooted and all of this kind of stuff. But of course, you have to trust the project. So that was what was happening there. So you have to trust the project, which will activate the relevant extensions and import the project into Visual Studio Code. So I'm trusting it, and that'll set up my project inside my IDE, so I can start developing out of the box immediately. So like I said, you have a build.gradle. And you're with Micronaut. Other than that, it's just like a standard Java project where you have a main method. So if you're used to something like, again, Spring or other frameworks, there is basically a main entry point into your application where you can start up and start building your application. And this is how you kind of spin up the app and get it operational. There's also a JUnit 5 test that gets created. So this JUnit 5 test is pretty simple in that but a big difference is that we had a set of JUnit 5 extensions. So when you add @Micronaut test to any JUnit 5 test, what happens is it will spin up Micronaut and allow you to dependency inject using just JSR 330 injection annotations, any component in the application. So all this test is actually doing is verifying that the application can start up select correctly. So I can run this test directly from my IDE, and it will spin up Micronaut and make sure it's up and running. And that's how easy it is to get started writing Micronaut applications. And of course, I can go to the main method, and I can click Run Main, and I can bootstrap the application. And like any kind of server application, it's going to start up on port 8080. So you can see down there, my server is up and running on port 8080. I can also run the application in what's called continuous mode. And in that case, it will, every time I make a change to the application, it will auto-restart. A lot of developers do like that experience of running the app and then seeing their changes and then having it auto-restart and seeing their changes, et cetera, et cetera. I don't tend to use that feature very much personally. I'm more of a kind of test-driven guy, so I like writing tests and then making assertions and seeing my application work. But each to their own. Each person can do whichever pattern suits your needs. So what is the next thing that we can do to take this to the next level? Let's write a simple hello world or a simple API in Micronaut. So what I'm going to do is I'm going to create a new, I'm going to use a new from Java template, and I'm going to use record, and I'm going to call it person. There we go. So here's my person record. And what I'm going to do is I'm going to add some data to this, some record components. So let's do like string first name, string last name, int age, for example. And I've added 3 components to my record here. And let's expose some data over a REST API. So what I'm going to do is new from Java template. I'm going to create a Java class, and I'm going to create a person controller. There it is. So much like other frameworks out there, we have a set of annotations you can use, where you can say this is a controller that maps to the people endpoint. And we can say, I'm going to expose a list of person, like so. And I'm going to turn list of, and we're going to do new person. Let's do Fred, Flintstone. There we go. 45. And let's do, say, Barney Rubble. And expose 2 people over my REST API. There we go. So how do I make this method exposed over a REST API? So I've already mapped in my controller to the people URI. Now, all you need to do is annotate a particular method with one of the HTTP annotations, so in this case, get. Now, if you do prefer JAX-RS annotations, we do have extensions to Micronaut to support both Spring annotations and JAX-RS annotations. One of the cool things about Micronaut is that we've decoupled the source code level annotation model from the actual runtime. So we can actually transpile and compile and interpret both Spring annotations and JAX-RS annotations and treat them the same at runtime. So I've annotated this method with @get, and that essentially exposes it over HTTP. So now, how would I write a test for this? So what I'm going to do is I'm going to pop over to my test, and I'm actually going to create a new test. And I'm going to say this is going to be a person test. And I'm going to make this a Micronaut test by annotating @Micronaut test. And what I'm going to do is I'm going to define a client that I'm going to use for the scope of this test. So Micronaut has a really nice decorative HTTP client. And all you have to do is define interfaces and then annotate them with @client, like so, and specify a URI of the server that you want to talk to. So I want to talk to the people URI of my current server, and I want to send, again, a GET request to get a list of people back from my server. And I want to send requests back and forth to get my people. So how do I use this client now? So obviously this is an interface. And the fact that I've annotated this with @Micronaut test, what it's going to do is it's going to bootstrap my application in the scope of my test. And then I can dependency inject any components. So I can write a simple test here by saying @test. And we're going to say test list people. And we're going to dependency inject my person client directly into my my test method here, so it's immediately usable. And that's the benefit of using @Micronaut test. I can dependency inject this component in here, and I can use it. And I can say, list me all the people. And we can extract that into a variable. And then we can write an assertion. I can say import assertion. We can say assert equals to people size. And if we want, we can switch that into a static import to make it look prettier. And there we go. We have a test for the code that I've just written. So one of the great benefits of Micronaut is startup time performance, is performance overall. And the fact that when I can write a test that's going to spin up my entire server here and do a full integration test, making an HTTP request to my server, getting the results back, and when I execute this test, the execution time and the time it takes to actually execute is minimal. Yeah. There's a lot of frameworks out there that have extensive mocking facilities where you mock and to avoid starting the server because it starts so slowly, you have to write all these mocks, or you have to like bootstrap only a subset of your application. In Micronaut, we have you can have thousands of controllers, large code bases, and you don't have that same level of concern of only having to bootstrap a subset. Text execution time remains super fast, and I can be super productive. And that means you write a lot more functional tests, right? I see it a lot in code bases in the past where people deprioritize writing functional integration tests because their application starts too slowly. No, that's not a good way to go. But they write lots of little unit tests. You can write better tests that execute your whole application when you use a framework like Micronaut, and it remains really fast. So this is sending a request. This is making a full HTTP request to the server. It's getting the result back. And if we want to see, actually what's going on here, you can go into your logback configuration, and I can say I'm going to add a logger, and I'm going to say this is i.micronaut.http.client, and I'm going to set the level to trace level logging, like so. And we can run that again, and you'll see that if we look at the data coming back from the server down here, you can see my record is being converted back into JSON and sent over my REST API. So that's how that's more like a hello world example, right? It's pretty simple. There's not a lot going on in this example so far. It's just returning some hard-coded data. So how can we? What else can we do that's exciting and different in Micronaut? So one of the things that one of my favorite features of Micronaut is Micronaut Data. So Micronaut Data, I have a long history with data access toolkits. When I was working on Grails, we created a database access toolkit called GORM, which I think was really innovative in the Java space at the time, because you could define an entity and you could say, person find by the first name or find by whatever, and obviously it was tied to the Groovy language. And then later, when I was working at Pivotal, we started the Spring Data project, which was kind of based on the same kind of syntax. So kind of Micronaut Data is like my kind of passion area in the framework, because I have this history with data access toolkits. And what makes it different is that we essentially moved all the computation of the query logic into the compiler, right? So the way GORM and Spring Data work is they do this runtime analysis, right? They analyze your classes, they analyze your entities, and then based on that, they runtime compute the queries that you want to execute, which adds a kind of overhead to the runtime, right? With Micronaut Data, what we did was we shifted all that to the compiler. So at compilation time, it does the computation of the queries. So at runtime, it's just ready to run. And because there's no reflection, there's very little overhead. And in addition to that, we have different backend implementations. So one of those is Micronaut Data Jdbc. So what you can do with Micronaut Data Jdbc, and it works really great with records, is you can take any record and you can say, this is going to be a mapped entity, right? And what that'll do is it'll say, this is going to map to a person table with a first name column and a last name column and an age column. But we try and encourage people not to think about this being a one-to-one mapping to a table, but rather a one-to-one mapping to a result set, right? So Micronaut Data Jdbc is not an object relational mapping tool. It doesn't have lazy loading. It doesn't have sessions. It's a simple data mapper, right? I have this SQL result set. I want to bind it to this record. End of story. Stateless, simple concept, very different to like JPA, which has like a lot of complexity, statefulness, etc. This is designed for people that like SQL and like being productive and in control of their result. So the only thing I'm going to add to this is an ID column. So I'm going to add an ID. I'm going to make this a generated value that is the ID, and it's going to be nullable, right? Now, this immediately will probably break my constructors that I was using over here, as you can see, because now I have to pass in a null ID at the beginning. But you can use, records actually support multiple constructors, so you can make that prettier by defining a secondary constructor in your record that calls the primary constructor with a value of null, like that, which is a really nice feature of records, that you can define these secondary constructors. So what I'm going to do next is how do we read and write these person entities to and from the database? So let's figure out that. So what I'm going to do is I'm going to create a new Java interface called person repository, like so. And I'm going to annotate this with @Jdbc repository. And I'm going to I'm going to use the dialect of H2, so I'm using an memory database at the moment. And I'm going to extend from CRUD repository, passing in the entity type and the ID type. Now, if you're familiar with Spring Data, again, we implemented these same concepts, the same patterns, the repository pattern in Spring Data. And from there, you can start using your repository. So one of the things I'm going to do straight away is go over to my application class, and I'm going to make it a singleton component because I want to dependency inject my repository. So I can dependency inject my repository into my application class. And one of the things in Micronaut that we really encourage is the use of constructor injection. So, so what is the difference? So over here I'm using, or over here somewhere I was using field injection in this test. So this is like injecting a field. And that has more, it's more likely that you're going to get a null pointer exception, or it doesn't really express the requirements of this class. So I way prefer to define that this class requires this component and just have Micronaut dependency inject this into my application class, and that's really easy. I can then define an event listener that is transactional, that listens for the startup event, so when my application starts up. And we can go over here and we can say repository, save a bunch of records to my database, and I'm going to go over here and steal this from here, and we're going to save these guys into the database when the application starts up. So this is a way to run some logic when the application starts up. An event listener that listens for the startup event that runs transactionally. If I had other statements in here, other inserts, and anything went wrong, the definition of @transactional will roll back the transaction, and we won't have a problem. So, but yeah, this with the repository, what I'm doing is I'm calling save all here, and this is one of the methods that CRUD repository provides you. So it provides save, update, update all these different methods to perform basic CRUD operations. I can then go over to my controller, and I can say inject my person repository into private final person into my controller here, generate a constructor for that, and I can say repository find all to implement that logic. So this is actually failing to compile, and the reason for that is find all actually returns a iterable by default, and I'm returning a list. So one of the cool things that you can do in Micronaut Data is you can override any method. You can basically say find all method returns iterable, and instead of returning an iterable, it'll return a list, and then it will override that functionality from the parent interface just using covariant return types, which is really cool. And with that, I have more or less implemented some basic database access logic in my microservice here, which hopefully, if I run this now, and it all goes to plan, that it will still work. So it did, the test passed, and you can see that now the response coming back, we got some IDs assigned from the database that I'm using. So we have persisted some data when the application starts up. We're testing that data is there in my test, and it's all working nicely. Now, you may have remember what I mentioned, that Micronaut is based on annotations, yes, but it's also compile time checked. So what do I mean by that? So let's implement a different type of method. So let's say we're going to have a get endpoint here, and it's going to allow us to look up a person by their first name. I don't know, for example. And what I'm going to do for that is I'm going to use a URI variable. And one thing, we also support optional. So like if there was like no result here, you could make this optional, or you can make it nullable. If you don't, then it would like throw an exception. But I can say get, for example, by first name, like so. And I can say return repository.find by first name, like so, to implement this logic. And this is what, again, the repository pattern in oops, what have I done there? So I think I accidentally deleted something. There we go. So what I've defined here is a find by first name method that's going to use find a person by their first name. And this is going to be automatically implemented as a SQL query for me at compilation time. Now, I could get into full control of that query by using the query annotation. I can add a query here, and I can say select star from person where, and basically write my own query and be full control of that. That's one option. Another nice thing about the ID tooling that we've been building as well is, I can write different kind of finders, and I can say, for example, find by age, and I can get completion here. I can say find by age between int start and int, and I get some level of code completion from the ID automatically of the different possibilities, which is really cool. But anyway, in terms of type checking here, getting back to the point, like, as you can see, you've got some various aspects that could go wrong here, right? We have a first name variable in this URI, and it binds to a parameter. So, like, for example, if I type name here, you can see that the framework fails to compile, right, in multiple places. Obviously, it fails to compile over here because of Java, but it also fails to compile because the route declares a URI variable named first name, but no corresponding method argument is present. So I'm getting compilation time checking that I'm using the annotation programming model in the supported way. So that's really important, and that I get this kind of compile time checking happening automatically for me. And in another way as well, if I go back to my repository, if I do public person find by, I don't know, nom, whatever, and string, something that's clearly not valid, I get compilation time checking, right? So I can see here that my code won't compile if I define a method in Micronaut Data that is not valid. Yeah, I'm actually getting a Java-C compilation error, and this is because we integrate directly with the Java-C compiler, and to make sure that it is valid. And we also have like direct integration with validation rules as annotations. So, for example, I can say that the name shouldn't be blank, and this should be a positive number, and we can annotate directly our record to make assertions that the data is correct that I'm testing. Yeah. So the framework is it's got a lot of different features, and I've only brushed kind of the surface of what's possible. But once you've actually built your application into a native, built your application, how do you get it running? So one way is to just do like GraalVM assemble or Maven package, and that'll assemble it into a runnable jar file, which you can deploy in JIT mode. So I can say java jar build libs and just run my jar file, and I have a runnable application. I can deploy that. I can package it into a container. Speaking of containers, you can also do GraalVM Docker build and basically package your application into a Docker container out of the box. We have an extensive set of Maven and Gradle plugins that have knowledge of packaging applications into into common formats and like Docker containers. And then, of course, to go to native, you can say GraalVM native compile, and this will compile the application into a native image. Now, this is going to perform a closed world static analysis of the application. So if you haven't heard of or unfamiliar with what native image does, it analyzes your application at build time, and we have some extensions into native image that make that even better. But it's going to look for all the reachable parts of your code. So it's going to find out where there dead code paths exist and eliminate those. It's going to look at the kind of closed world static analysis of the entire application. Now, this whole process of building a native image does take time, but as Elena pointed out in the previous presentation on GraalVM, if you went to that, there is a new quick build mode where you can kind of effectively halve your native image build time, and by passing in an additional flag. It's not good for production usage, but it's good for like quick tests and so forth, where you don't want to wait the kind of full length of time before you've built a native image, because the process does take some time. And so the quick build mode is a good option for that. But basically, the analysis is going to do this computation and produce an executable that is runnable on this platform. So what I'm doing right now is I'm building a native executable that will run on this Mac specifically. So it's designed for this Mac. We also have in Micronaut the ability to build native images in Docker containers, because that's really common, right? I want to on this Mac, I want to build a Docker container that runs on Linux in the cloud. So we have the specific ability, and that's GraalVM Docker Build Native, where it will package up a native version of your Docker container, which you can push to a container registry. We have great integration with Kubernetes, so that we automatically generate Kubernetes descriptors, and you can push those containers up to whatever container registry that you're using in your cloud. We also have packaging options to build native images into AWS Lambdas or Oracle functions, and so on and so forth. But once you have a native image, it's just a matter of running that, and you can see that with, I think it wasn't happy because of that, but basically, I don't know what's going on there. But basically, you can see that the startup time is down to 37 milliseconds for this application. And if we look at the memory usage, now this is an application that's using Data, it's using Jdbc, and you can see the memory usage has dropped significantly. I didn't show you the JIT memory consumption as a comparison, but it's basically like a fifth of the memory consumption, right? 17 meg, really small, efficient native images that you can build. And this is a full database app, right? That you can deploy to the cloud scenarios, et cetera, et cetera. Okay, so I didn't have as much time as I wanted to because of the slightly delayed start, but in terms of the getting started experience, you can go to start.micronaut.io, like I mentioned. Start building an app today. There's great IDE support, both in IntelliJ, and VS Code. I've demonstrated to you the VS Code integration today, but there is, equally good support in IntelliJ. We have great documentation at docs.micronaut.io, a full user guide, and a really extensive set of guides on creating a range of different use cases, integration with data, microservice concepts like service discovery, distributed configuration. There's really a lot to cover, and one day I hope to be able to return to doing full workshops on Micronaut where I get like 3 hours to explain everything that is possible, because there's really a lot. And of course, GraalVM, you can find out more at the GraalVM docs. So in summary then, Micronaut and GraalVM are kind of leading this AOT revolution towards doing more at build time. Server-side Java has really changed a lot in the last 3 years since Micronaut and GraalVM and so forth started pushing, for more efficient workloads, more efficient applications natively running in containerized environments. And yes, AOT does sacrifice compilation speed, but you gain the ability to take Java applications like I said, to places that they could not go before, right? From IoT to serverless to low memory microservices. And it's a reality today. The tooling is getting more and more mature every day, and it's a great time to start trying out these technologies. Thank you very much. I hope you had enjoyed the presentation, and if you have any questions, I'll be at the conference until Thursdays, and thank you very much for your time.